In this video, we're going to review how to solve equations by opposite operations or order of operations. So just a reminder before we get started of what solving actually means. If you're asked to simplify something, that just means you're trying to condense it or make it simpler or shorter. So simplifying just means making it simpler, condensing it, making it as simple as possible. If you're asked to solve something, so solve an equation, that means that you are looking for the value of a variable. So your final answer is going to be x equals something, x equals 5, or maybe your variable is a. Your final answer will be a equals something. So that's what solving means. So we have some tools in our toolkit from grade 9 and grade 10. We have even more, but these are the ones that we're going to just practice today, which is applying opposite operations in order of backwards bedmass. If you've never thought about it this way, we're going to review it together. Eliminating fractions using multiplication and collecting like terms. So those are going to be our tools. So let's go ahead and get started on the first one. So this example asks us to substitute the known value in each equation and then solve. So here I'm given the equation of a line, and I'm told I'm asked to solve for the unknown variable. So I'm given y. That means I've got to solve for x. So we've already taken a look at what this looks like graphically. So we should get the same answer algebraically as what we got graphically. So first thing I'm going to do is substitute what I know. I know this guy right here. I know y, so I'm just going to replace it. So y is just 4, so here I go. 4 is equal to negative 3x plus 2. There's no fractions here. There's nothing that complicated about this equation, so all we're going to do is get x on its own. I want to do a quick reminder of what number to move first. You might be looking at this and think like, Miss, we did this in grade 9, which is absolutely true. This is a question from grade 9, but we're going to make it more complicated very quickly. So I want to go over the basics with this guy right now. So we got to get x by itself. That's the unknown variable. So I have to move two numbers. I have to move this negative 3 and I have to move this 2. It doesn't matter how complicated the equation is. When we are moving numbers across the equal sign, so away from x, we're going backwards, getting x by itself. So we do it in order of backwards bedmass. So we go backwards with bedmass, okay? So we're going to do any addition and subtraction first. We're going to get rid of that. Then we're going to get rid of any division and multiplication. Then we're going to get rid of exponents, and then we're going to get rid of brackets. So division and multiplication, there's an arrow here. It doesn't matter the order. Same with addition and subtraction. So really quickly, that negative 3 is multiplying against x, so I'm just going to check it off. And this plus 2 is adding against x, so I'm just going to check it off. If you don't need to use this for a simple one like that, that's fine. If you are completely forgot everything that you did in grade 9 and 10 and need to use this guy for something like this, do whatever you need to do. Okay, so we're going to get rid of them in order of backwards bedmass, so we're going to get rid of the addition first. So to get rid of this guy here, the adding 2, we're going to subtract 2 on both sides. So it's going to end up looking like this. I'm going to subtract 2 really on both sides, so that's how that one goes away, but it's just going to show over here. Okay, and simplify, so we've got 4 minus 2 is 2 is equal to negative 3x. Okay, and now we've only got one thing to deal with, which is that negative 3, that multiplication. How do you deal with multiplication? We're going to do the opposite of it, which is division. So we're going to divide by negative 3 on both sides. And on the left, we're left with negative 2 over 3. And on the right, we just have x, because negative 3 divided by negative 3 is just 0. So we're done. I'm not going to change that to a decimal because it's a repeating decimal. It's going to be 0.666666. So I'm just going to leave it like this. So the only tool that we needed for that question was just applying opposite operations in the order of backwards bedmass. So let's take a look at another example where we might have to use one of these two. All right, so here's another example. We have an equation. This is linear. There's no exponents greater than 1, so this must be a line. And we're asked to find what is the value of x if y is equal to negative 2. So the first thing I'm going to do is I know what y is, so I'm going to replace it. So here we go. We have 0.5. Here we go. Sorry. Okay. 0.5x plus 4 instead of y, I'm going to put negative 2 is equal to 1.5x. I'm going to simplify quickly, make this pen a little bit bigger. So we've got 0.5x, and then 4 times negative 2 is negative 8 is equal to 1.5x. Okay, so opposite operations, I have to get x by itself. Problem, we've got two x's. So we're going to use one of the other tools in that toolbox, which is collect like terms. If we've got like terms to add together, let's do it. So I'm going to bring both of them on one side. So I'm going to bring this guy, the 0.5x, onto the other side. So I'm just going to do the opposite. If it's plus 0.5x here, I'm going to subtract 0.5x on the other side. So I've got negative 8 is equal to 1.5x minus 0.5x. If you're having trouble understanding why that is, that's something that we did in grade 9. And you can just talk to me and I'm going to send you a video on it from our grade 9 class. Okay, so we just have 1x is equal to negative 8. 1x is the same thing as x, so we're done. We have x is equal to negative 8. Ta-da! Done. Let's try 4 more difficult examples. So taking a look at something like this, no substitution, it just says solve. So we just got to find x. So a couple things that we could do. We have to get rid of the plus 4, we got to get rid of the negative 3. If we go in opposite operations, we have to do the multiplication before the brackets. But maybe you're looking at this and thinking, why don't I just distribute this in? And maybe that'll make it easier. Whatever way works for you is totally fine. So if you see that you want to do this, go for it. So let's expand that in. So it makes negative 3x minus 12 is equal to 2. And now this is a question just like we did in example 1. We got to go backwards BEDMAS. I'm going to deal with this subtraction first. I'm going to bring that minus 12 onto the other side. And I've got negative 3x is equal to 2 plus 12. And that's going to make 14. And then the last thing I got to do is get rid of that times negative 3. So I'm going to divide by negative 3. The final answer is going to be a repeating decimal, 4.66666. So don't change it. Just leave it as the fraction because that's the most exact answer. Don't leave a negative at the bottom of the fraction. Just pop it up to the top. So it's going to be negative 14 over 3. And we're done. How about an example like this? This looks ugly. It looks ugly because we have multiple x's, so I know I've got to collect like terms. And also it's ugly because of this fraction. So one of the remaining tools that we have for solving equations is this guy right here. Eliminate fractions by using multiplication. So that's the easiest way to deal with this. So let's deal with this by actually just eliminating it completely in terms of the fraction. So how do I get rid of this fraction? Think about it as division. So this is just dividing by 2. So if you want to get rid of dividing by 2, I got to do the opposite, which is multiply by 2. So I'm going to multiply this whole fraction by 2. And what's going to happen is 2 divided by 2 is just going to be 1, so that's going to cancel out. What am I going to do to the other side? I can't just multiply one of them by 2. I have to multiply everything by 2. So I'm going to multiply this guy by 2 and this guy by 2. So let's see what the next line is going to look like. Taking a look at this, it looks like a disaster, but this just says 2 divided by 2. So those 2 are going to cancel out. Gone. And then what am I left with here? I'm left with x plus 3. And then here, it's kind of confusing because I used an x instead of time. So let me just change that so that there's not double x's here. So I'm going to change this to dots instead. Okay, so here we go. Everything's getting multiplied by 2. So what's 4x times 2? That's just going to be 4 times 2 is 8, and then we have an x. And then I've got negative 1 times 2. That's just going to make negative 2. So we've eliminated the fraction by just using multiplication. It's not the only way to do it, but it's maybe one of the easiest ways to do it. So now this looks like an example that we did before, where we've just got x's on both sides. We're going to collect them and get x by itself. So I'm going to bring, it doesn't matter which side you bring it to, but I'm going to bring the x onto this side. So I've got 3 is equal to 8x. This is positive x on this side, so I'm going to make it negative x on the other side. And then I have minus 2 here. I realized that I want to bring this -2 and 3 together. If you already saw that and you did it at the same time, great. So instead of -2 on this side, I'm going to have +2 on this side. So this is going to be 3 plus 2 is equal to 8x minus x is going to be 7x. So 8x minus 1x is 7x. Let's keep simplifying. 3 plus 2 is 5 is equal to 7x. Let's get rid of that 7 by dividing by 7, dividing by 7. And we have x is equal to 5 over 7. And we're done. Let's try the last two. How about something like this? Does this look intimidating to you? We have gone all the way from grade 9 to grade 11 now. So let's figure out what we're doing. Is there any fractions? No. Is there any collecting like terms that we can do? No. So we're just using backwards bedmass here. So we have to get x by itself. I have to move the -4, the -1, and the squared. If you're ever unsure of what to do first, just write out bedmass. So what do we have going on here? We have this -4 multiplying against the x. So that's multiplication. So I'm going to check that guy off. I have this 1 subtracting from x, but it's in brackets. So that counts as brackets. So I'm going to check brackets off. And then we have an exponent. So I'm going to check off exponent. And now I just have to get rid of them in backwards order because I'm not simplifying here. When we're simplifying, we use regular bedmass. I'm moving these things onto the other side, undoing the bedmass. So I got to go backwards. So I'm going to move the multiplication first. So here's the multiplication. How do you get rid of a times -4? Well, we know what to do. We're just going to divide by -4. So I'm going to divide by -4 on this side. And I'm going to divide by -4 on this side. What is going to cancel out here? The -4s. So let's do it. Cross out those -4s. What are we left with over here? -36 divided by -4 is going to be +9 equals bracket x minus 1 squared. Just a side note, I know that there's someone that's wondering, Miss, why don't I just multiply this in like this? And I cannot do that. The reason I cannot do that, like the example that we did before, is this exponent. I cannot do multiplication before I do exponent. So when I'm simplifying just makes something simpler. I always have to go in regular bedmass order, just like we've learned from grade 4, whenever we started doing bedmass. We only do backwards when we are undoing whatever's going on here. So when I'm simplifying, I still have to follow bedmass, and exponents come before multiplication, so I cannot do this in this case. That's why I have to just get rid of that -4, which is what I did here. So I have now left over, I've got exponents and I've got brackets, and I have to do the exponents first. So how do you get rid of a square? What's the opposite? We are going to square root. So we're going to square root both sides. So let's keep simplifying. So if I simplify the left, the square root of 9 is 3. And then over on this side, the square root and the squared are going to cancel each other out. So all we're going to be left with is what's left in the middle, which is going to be x minus 1. And last but not least, let's get rid of that -1 by making it +1 on the other side, and we have x is equal to 4. So we already solved these graphically, and we did get the answer of 4, but we also got another answer. We got 2 answers for this when we solved this graphically, but algebraically we only got 1. The graph never lies, which means that we have done something wrong here. Let's take a look back at what we did and see if you can spot where we made a mistake. First thing that we did was divide it by -4. We've done that since grade 9. This seems normal. This seems right. How about this step? This is the weird thing that we did. We square rooted both sides and we got 3. But actually, if we are creating a square root, then we have to put plus or minus in front because there's 2 answers. The square root of 9 could be +3 or it could be -3. So I have to put a plus or minus in front of this 3. So I'm going to rewrite my answer because as soon as you have a plus or minus, the easiest way to deal with it is to make 2 cases. One case is going to be for the positive version of it, and one case is going to be for the negative version of it. So one of our equations is going to be positive 3 is equal to x minus 1, and we're going to solve that. And our other equation is going to be negative 3 is equal to x minus 1. So you're going to copy everything else, but we're going to write the two versions of 3. We have positive 3 and we have negative 3. And we're going to solve both of these equations now. So this one we've solved before. We got this answer already. I'm going to get rid of the negative 1, bring it over. It's going to be positive 1. So I've got positive 3 plus 1 is equal to x, and we have the answer of 4. 4 is equal to x. We had that one. Here's the equation, or here's the answer that we were missing. I'm going to bring this negative 1 onto this side to get x by itself. So I've got negative 3 plus 1 is equal to x. And negative 3 plus 1 is going to be negative 2, and that is what? X is equal to. So there's two answers. We have x1 and x2, and that is the same as what we found graphically. Last example. This one is super similar to the one we just did before. The only thing I've added is something here. So if you feel confident, pause the video, try it on your own, and just fast forward to see if you get the right answer. If your head is spinning and you really are still not sure what to do, stay with me. We're going to try this example. So we got to get x by itself. We have 2, negative 3 squared, and negative 1. If you are confused about which number to move first, just write out BEDMAS. So this first 2 is multiplying, so I'm going to check off multiplying. Then we have this negative 3. It's subtracting, but it's in brackets, so I'm going to count that as brackets. And then I have a square, that's going to be an exponent. And then it's minus 1. It's not in brackets, it's just subtracting on the outside of the relation, so I'm going to count that as subtraction. And then I'm just going to go in opposite order. I'm going to move things in opposite order of BEDMAS because we're moving things over the equal sign. We're undoing what's happened to x. So I'm going to deal with the subtraction first. So I'm going to move that negative 1 onto the other side. It's going to become positive 1. So we've got 5 plus 1. If you skip steps, that's absolutely fine. If you can do it in less steps than what I'm showing, there's no problem with that. So we got 6 is equal to 2x minus 3 squared. Can I expand the 2 in? No, I cannot because I have that squared. I got to do exponents before multiplication. So let's figure out what I can eliminate next. Subtraction, done. I can eliminate the multiplication next. So let's get rid of that times 2 by dividing by 2. So I'm going to divide by 2 on both sides, and I've got 3 is equal to x minus 3 all squared, because 2 divided by 2 is just 1. Let's keep going. After the multiplication, I got to get rid of exponents. How do I get rid of squared? I got to square root. So here we go. I'm going to square root both sides. But do not make the mistake we did in the example above. Anytime we are solving an equation and we create a square root, we have to put a plus or minus because there's actually two answers to that. So I have to figure out what the square root of 3 is. That's not a nice number. If you check in your calculator, it's 1.7320508, blah, 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 blah. So we're going to work with the decimal, not a big deal. If we have to work with a decimal in the middle of a question, take at least 3 numbers after the decimal point. So I'm going to change this number to, instead of plus or minus the square root of 3, I'm going to change this to plus or minus 1.732. And then I'm just going to finish up the rest of the equation. Square root and squared, those are going to cancel each other out. So the only thing I'm going to be left with is what's in the middle, which is x minus 3. So I have x minus 3. And at this point it gets confusing. So my suggestion is, as soon as you see a plus or minus, set up 2 cases. So I've got one case with the positive version and another case with the negative version. So I'm going to rewrite this. I'll do the positive version first. Positive 1.732 is equal to x minus 3. And the other case is, what if that thing was negative? So negative 1.732 is equal to x minus 3. So let's solve them. I'm going to get rid of, for this guy, I got to get x by itself, so I'm going to move that minus 3 over. And we have 1.732 plus 3 is equal to x. So that's just going to be 4.732 is equal to x. And the last one, this equation here, I'm going to move that negative 3 over, and it's going to become positive 3. So I've got negative 1.732 plus 3 is equal to x. And then I've got my final answer, 1.268 is equal to x, which matches what we got graphically. So we've got two answers, x1 and x2, and we're done.